So now let's look at our last topic, even and odd properties. To make the use of negative angles and negative functions easier to work with, recall the properties of even and odd properties. A function is even if f of x is equal to f of negative x, meaning that we have symmetry about the y-axis. A perfect example of this, maybe from a previous class, is knowing that y equals x to the second versus y equals negative x to the second are going to give you the same picture. A function is odd if negative f of x is equal to f of negative x, meaning that we have symmetry not only about the y-axis, but also the x-axis. Now I didn't leave a lot of space for that because typically when we have symmetry around both the x and the y-axis, we say that we have symmetry about the origin. So let's see how that helps us. What type of functions are the sine and the cosine function? So pause the video for a second and why don't you give that some thought and then come back. I'm going to start with the cosine function. So using the circle that we see down here at the bottom, let's just say that if I had the cosine of some angle t, based off of that circle, I would say that the output is x. Now, if I have the cosine of negative of t, now what is the output? Well, by looking at the circle, we can see that even though the y value has changed, the x value has not, and so it is the same. So which one of these is this like? Well, I think it's the even function, because notice that the only thing that changed in the even function was the input. We started with x, and we had that equal negative x, so the inputs were exactly the opposite, but the fact that they remained equal told me that this output had to be the same. So the cosine is an even function. And how about the sine function? Again, pause the video for a moment. I see, I'm going to do the same procedure, I see that the sine of t is equal to my y value. And let's see here, the sine of negative t, what does that equal? The sine of negative t is equal to negative y. So not only have the inputs changed, but the outputs have changed as well. And that is exactly what an odd function says. So notice that we started with a positive x in the original definition, and the new input was negative. We ended up with a positive on the f, and we started with a negative. So these two are just opposites of each other. That means that we have an odd function. So here's our official properties for even and odd trigonometric functions. The sine of negative t is equal to negative sine of t. That makes the sine an odd function. Cosine of negative t equals the cosine of t. That makes that an even function. And how about tangent? We didn't talk about tangent, but based off of the definition that I have here, which one of these does it look like, odd or even? And I would say, since not only do the inputs change, but the outputs, that this is an example of an odd function. So let's see, how does that help us? Find the exact value without using a calculator. And our first one is the sine of negative 420 degrees. The sine of negative 420 degrees, because sine is an odd function, we can say that the sine of negative 420 degrees is equal to negative sine of positive 420 degrees. And I believe on a previous slide, we said that the sine of 420 degrees was equal to the sine of 60 degrees. Go back a couple of slides just to convince yourself of that. And we know that the sine of 60 degrees is square root of 3 over 2, and so that's what this final answer is. And let me separate these out. I'm writing too much or writing too big, I guess. There we go. So what is the cosine of negative 30 degrees? Let me just move over here for that one. The cosine of negative 30 degrees, according to my cosine property, is going to be the same thing as the cosine of positive 30 degrees. And what is the cosine of 30 degrees? We should have that memorized. That's going to be root 3 over 2. And finally, what is the tangent of negative 21 pi over 4? The tangent of negative 21 pi over 4, because tangent is an odd function, is going to be the same thing as negative tangent of positive 21 pi over 4. And we've seen 21 pi over 4 on example 1. We said that the tangent of 21 pi over 4 was 1, and so this answer is now negative 1. If you have any questions on this, make sure that you ask or you post them to the corkboard.